Welcome to section 4.5, day 1, tangent and cotangent functions. Today's objective is to graph transformations of tangent and cotangent functions. So first, here are the properties of the tangent function. The domain is all reals, but x cannot be pi halves plus any integer multiplied by pi. For pi halves and any addition or subtraction of pi from pi halves, we have discontinuities. We have vertical asymptotes. Our range is from negative infinity to infinity. It just keeps repeating. Our x-intercepts happen at n pi, so pi times any integer is where we have our intercepts. Our y-intercept, it goes to the origin, so our y-intercept is 0. Like I said, we have infinite discontinuities where our vertical asymptotes are. Our symmetry, this is an odd function. It does go through the origin, and it is an odd function. There are no extrema because these go to negative infinity to infinity at each of the vertical asymptotes. And we do not have end behavior because this thing oscillates between negative infinity and infinity as we go from left to right. The period of the tangent function is the distance between any two consecutive vertical asymptotes. So our period for this is pi. We have seen this function before, except we had cosines and sines instead of tangent. The idea behind it all is the same. The A is your amplitude. Your B is used to help find your period and your phase shift. C is your phase shift. And your period for this one is pi over the absolute value of B, where with the sine and cosine it was 2 pi. With tangent and cotangent, it is pi. So we're going to sketch the graph of tangent of x over 3. When we do these, we want to find our period first. Then we're going to find our vertical asymptotes and use those to create a table. So for our period, if you recall, our period is, in this case, our normal period is pi. Our b in this case is 1/3. And if you simplify this, you get our period for this function is 3 pi. We are not shifting this anywhere. We are horizontally stretching this. We have that 1/3 x. We're going to be stretching this horizontally because our period has gone from pi to 3 pi, so we're stretching it out horizontally. And the way we find our asymptotes is we take bx plus c, and these are at negative pi halves, and at pi halves, these are where our normal asymptotes are. And we take bx plus c and set it up to our normal asymptotes with a non-transformed tangent function. Well, in this case, our c is 0 and our b is 1/3. So we have 1/3 x equals negative pi halves. And when you get this, you get x is negative 3 pi halves. Do the same thing on the other one. We get 1/3 x equals pi halves. Multiply both sides by 3, and you get x equals 3 pi halves. These are our vertical asymptotes that we're going to use to start. And then our period is 3 pi, so it's just going to keep repeating every 3 pi. So let's see what that looks like on the next slide. So we're going to sketch a graph of tangent over x cubed now. So now we have step 3. We're going to make a table. On the previous slide, we discovered that we had a vertical asymptotes at here and here. So in my table, I use the parent function first. And normally our vertical asymptotes are at negative pi halves and pi halves. That's what my endings are. The x-intercept with the tangent and cotangent functions is halfway between the asymptotes. If you go halfway between negative pi halves and pi halves, your x-intercept is at 0, right here in the middle. And then when we do our graphing, we want to do intermediate points, is what we call these. So we take half the distance between the vertical asymptote and the x-intercept. And that's where we get this right here, that negative pi fourths and the pi fourths. We get that because that's halfway between the x-intercept and the vertical asymptotes. That's the parent function on the top line. Then on the bottom line, we are going to apply our transformation. Since our b is 1/3, we do the reciprocal basically and our period's been stretched to 3, so we're going to multiply our x by 3 because we have that horizontal stretching going on. So when we multiply, we get negative 3 pi halves for our first vertical asymptote. We multiply the intermediate point, we get negative 3 pi fourths and negative 1. Our intercept stays the same. Our intermediate point on the right side is 3 pi fourths over 1. And then we multiply pi halves by 3, and we get 3 pi halves. Now we're going to graph this. Okay, so I'm going to graph this right here. This is the piece I graph from my table. Okay? And then we're going to repeat this every 3 pi. So between negative 3 pi halves and 3 pi halves is 3 pi. If you actually found the distance between them, you'd have 6 pi halves. 6 pi halves simplifies to 3 pi. So we're going to just repeat this every 3 pi. And what we do is we make a cycle to the left of what we've done at the beginning and to the right. So we take negative 3 pi halves, and we're going to subtract 3 pi to get to negative 9 pi halves. That's my other vertical asymptote. We're going to add 3 pi to 3 pi halves to get 9 pi halves. Our next vertical asymptote to the right. Since the period is 3 pi, everything happens every 3 pi. So my x-intercept was at 0. My next intercept to the right is at 3 pi. And to the left, it's at negative 3 pi. We do the same thing for the intermediate points. Just add and subtract 3 pi from them to get to the right and left. These should all mirror. They should all look the same. We have 3 cycles, the one we did in the middle, and then we copied it on the left and to the right. All right, this is how we graph our tangent function. All right, now we're going to graph y equals negative tangent x over 4. This has a reflection. If you're asked how this is related to the tangent function, this is reflected over x. And we actually have a horizontal stretch you're going to see in a second. All right, so we have to find our period again. And again, our period normally for tangent is pi. It's going to be over 1/4. And when we simplify this fraction, we get 4 pi. So our period is 4 pi. We want to find consecutive vertical asymptotes. To find those, we take bx plus c. Normally, our vertical asymptotes are at negative pi halves and at pi halves. We're going to plug in our b. We get 1/4 x equals negative pi halves because c is 0. And we get 1/4 x equals, there should be a positive, should be a pi halves here. You do both of them, you get 4 times negative pi halves is negative 4 pi halves, which is negative 2 pi. Multiply this one by 4 and you also get positive 2 pi. So we are having vertical asymptotes at negative 2 pi and 2 pi. Halfway between those will be our x-intercept, which is at 0. We did not shift, which makes sense. All right, we're going to make our table. So we have our parent function here on the top again, what it usually is, and then we're going to apply our transformation. Since our period is now 4 pi instead of pi, we multiply the x variable by 4. We have a negative out front of the tangent, which is a reflection, so we multiply the y-coordinate by negative 1. And then when we do this, we find our vertical asymptotes at negative 2 pi now instead of at negative pi halves, which we saw on the last slide. Our x-intercept, like I said, is halfway between the two verticals, so it's at 0. And if you did the transformation just off your point, 4 times negative pi fourths is negative pi, and negative 1 is positive 1. So we have a table of values we can graph. So here's our sketch of our graph. I did the one cycle here in the middle. This is my initial cycle of my transformed parent function. Since our period is 4 pi, this right here is a 4 pi period. This right here is a 4 pi period. And we basically duplicate the graph in those two regions. Originally, we had an x-intercept of 0. If we subtract 4 pi from that, we have an x-intercept of negative 4 pi. Add 4 pi to that, and we have our x-intercept for other one at 4 pi. This is a reflected one, so you'll see that it's upside down compared to what the parent function would be. That is the graph of the opposite of tangent of pi fourths. Now we're going to do a shift. So here we have the opposite of tangent and x plus pi halves. So here we have a shift and a reflection over the x. And if you recall how to find your shift is negative c over your b, the absolute value of b. Well, our c is pi halves, our b is 1. This is just negative pi halves. So we are shifting left, pi halves. So our period, we do the same thing. This should hopefully be in pretty routine now. Our period for tangent is pi. Our b is 1. So our period has not changed. We're going to find two consecutive vertical asymptotes. All right, so we take bx plus c, our normal asymptotes at negative pi halves. We have bx plus c, our other normal asymptotes at pi halves. And we plug in our numbers. Our b is 1, so we have x. Our c is pi halves. Do the same thing on the second one. I'm going to set both up. We subtract pi halves from both sides. And when you have negative pi halves minus pi halves, you get our vertical asymptotes at negative pi. These ones, we're going to take pi halves minus pi halves. You get 0. So our other asymptote's at 0. So we shifted everything to the left by pi halves. Now we have our vertical asymptotes at negative pi and 0. And again, we're going to use this to start out. Here's my parent function again on the top. We did a shift to the left of negative pi halves. So for my transformation, I subtract pi halves from the x, and my y, I am going to multiply by negative 1 because we have a reflection. So here's my table with my transformation here on the bottom. And again, your intercept is halfway between your two vertical asymptotes. Then we do intermediate points halfway between the x-intercept and the vertical asymptotes. And then we graph it. And then we're going to make a cycle to each side of it. So here is my graph. Here's my initial. Here's my vertical asymptote. And here's another one. Here's my other vertical asymptote. It's not really shown very well because I have the y-axes there also. But those are my two vertical asymptotes. And then I duplicate a cycle to the left and a cycle to the right. My period is still a pi, so from negative pi, subtract the pi, you get negative 2 pi. From 0, add a pi, I get to pi. All right, that is doing tangent functions. Cotangent function is similar to the tangent function, except for now we have, for cotangent, it's x over y. So we are actually flipped upside down, and we're actually shifted off of the origin a little bit. So the domain again is all reals, and now as long as x is not a multiple of pi, that's where all of our vertical asymptotes are at multiples of pi. Our x-intercepts are at pi halves plus a multiple of pi, because our period is pi, so they repeat every pi. There are no y-intercepts in this one because the vertical asymptote is the y-axis, and we have infinite discontinuities at these vertical asymptotes. This is an odd function. We are reflected across the origin. There are no extrema because it goes negative infinity to infinity. And we oscillate between negative infinity and infinity, so there is no end behavior. This is what a cotangent function looks like. So we're going to sketch the graph of y equals cotangent 2x. It's the same idea we did on tangent function. We look at our numbers. It's just cotangent 2x. There is no shifting. There's no reflecting. But we have a b, so we have a different period. So to find our period, p, we have pi over 2. So our period is pi halves. We are compressed horizontally. Okay, that's how it's related to the parent function. I want to find two consecutive vertical asymptotes. Same idea as what we did with the tangent function, except for instead of being at negative pi halves and pi halves, for cotangent, the asymptotes we look for are at 0 and pi. So we take bx plus c is 0, bx plus c is pi. And we solve, we have our b is 2, so we have 2x, our c is 0. So 2x equals 0. Then we have 2x equals pi. We divide it out, we get x is 0 for one of our vertical asymptotes, and x is pi halves for the other. Because we're compressing it, we're happening faster. Instead of doing every pi, we're doing every pi halves. From here, we do our table again. Here's our parent function on the top, and I'm going to apply my transformation to it to create my first cycle. Since our b is 2, we are going to multiply x by 1/2, and this is what we get. Our x-intercept was at pi halves, now it's at pi fourths. We have our vertical asymptotes on the ends that we found earlier. And then our intermediate points, we multiply by 1/2 and get pi eighths, and you get 3 pi eighths. And then we're going to graph it. All right, so here we have our graph. This is my initial cycle right here in the middle, is right there. And then I just duplicate it to the left and to the right, just like we did earlier. The biggest thing is setting up the tables to do the initial one. After that, it's all repeating. All right, that is all for section 4.5, day 1. When you do your assignment, make sure you do sketch 3 periods. The book only says to sketch the graph, but I want you guys to do a period on both sides. So get used to this, how these things repeat and how they cycle. So sketch 3 periods, one to the left and one to the right. Today we looked at graphing tangent and cotangent. Thank you for watching, and have a nice day.